we're now going to use the reflecting property. And the reflecting property is this really cool property that says if I have a focus in a parabola, then I can either take everything coming in to that parabola that's parallel to the axis and reflect it to the focus, or if I have a light source, I can reflect everything out and create a beam of light. So this is graphically what we're talking about. So here's our axis of symmetry, and if I have a bunch of signals coming in, every one of them that hits will be reflected to the focus. And this is how a satellite works. You aim it at the satellite and it sends a huge wave down, and each of those waves hits and is reflected to this antenna piece, which then translates the signal back to your TV so you can watch satellite TV or receive satellite information. The headlight, on the other hand, in a car, has a center focus that shines towards the reflective surface, and it creates this beam coming out, so you get the whole width of the beam. Now, to demonstrate how this works, we're going to talk about the Hubble telescope. So the parabolic mirror used in the Hubble telescope has a diameter, this is important, of 94.5 inches. Find the equation of the parabola if its focus is 2304 inches from the vertex. And then we want to know what is the thickness of the mirror at the edges. So what we have is a parabolic mirror like this, and it's more perfect than what I'm drawing, but this distance from here to here is 94.5 inches, and the focus is way up here because there's quite a bit of distance between there and that point right there, which is where we cap it off. So we're going to use the equation x squared, and we're going to assume the vertex is at 0, 0, is 4p, it equals 4py. And so the first thing that we're going to do is say, hey, we already know what the focus is. The focus is 2304. So that means P is 2304. So x squared equals 4 times 2304 y. Well, 4 times 2304 is 9,216 y. So here's our equation. Now we have our equation. To find the thickness at that point, that's from here to the vertex, what we need to do is plug in an x, and the x is half the diameter. So if we let x equal 47.25 and plug that in, then we get 47.25 squared equals 9,216y. So if we divide by 9,216, get out our calculator. Let's move this over to the other side. 47.25 squared divided by 9,216. This says that our thickness is approximately 0.2422485. So that's about how thick the Hubble telescope is at that furthest edge.